Okay? We use it, probably all of you have these in your homes, a rechargeable battery. We also use them in the metal refining process. So if something is gold plated or something is silver plated, okay, this is all through an electrolytic process. The anode is the impure, so like a copper ore, and the cathode is the pure metal, such as straight on copper. And so what happens is the copper anode dissolves and the pure copper is plated onto the cathode. So it looks like this. So the first reaction is what kind of reaction? What is this? Oxidation. Yeah.
Oxidization.
I know what you meant. Oxidation always occurs at the anode. And then the second reaction is and what type of reaction is this one?
Reduction.
There you go. Reduction always occurs at the cathode. Okay, so it's two steps that's happening at the same time. And what ends up happening is your cathode ends up being, depending on the quality that you're using and the amount of energy you're supplying, 99.99% pure. And the impurities either remain in the electrolytic solution if you've got two separate cells, or they fall to the bottom of the cell as a sludge. And what we see in the metal refining process, that's the downfall, is that the metal falls through in the sludge, which is now waste. And what do we do with that waste? And that's where you see what we call tailings ponds. That's where the waste goes, and it's just a big collection pit of the liquid and the leftover waste. And nobody right now has an ability to recover any part of that. And so there is I believe it's copper mine in BC, north of Hell's Gate area. And it looks like a moonscape because it's top excavated, and so it's just these mounds of ore everywhere. And the tailings pond is dammed at the top, and the town is at the bottom. So if the dam, it's a dam, and the tailings pond sits at the top. And yes, it meets all the regulations that it's lined and blah, blah, blah. But if the dam were to break, the town's water supply would be 100% contaminated. Okay? They've had this problem in the States. I don't know, ask your parents if they know about the Love Canal. So it's a waterway in the States that was contaminated with nuclear waste. So it's these sludge piles. That's slightly different, but it's the same idea that we have these piles of waste that we have nothing, like no way to, we can't bury them, we can't spread the liquid on the ground, we can't, they're just there. And that's where environmentalists have their arguments, is what do we do with this waste? So, if any of you feel the desire to become an environmental chemist, I strongly support you. Not you, Gracie? Okay. So electroplating, same idea, you're just going to put a thin layer of a desired metal on another object. And it's used for like jewelry, we see it, but it's also used for corrosion. Because remember when we looked at corrosion, and we want to have our reducing agent higher than our oxidizing agent so that it doesn't react. this is that same idea. We're going to put it on and it improves the quality of what it's containing. So you can electroplate bins so that they don't corrode. And we also do it with silver. Okay. I was going to say galvanized steel too, I think, is coated. I'm not 100% sure. Okay, for electroplating to work, it has to be the cathode and the anode has to be the metal you want to coat with. Okay, so let's plate a spoon. So in our beaker, we have our electrode and we have our spoon. Art is of high priority. And this is going to call on your memory from physics. What do the long lines mean?
Oh, it's like, isn't long positive?
Long is positive,
Yeah.
short is negative. So which way are the electrons going? Exactly. Electrons are flowing this way into the positive and out of the negative. This symbol here represents a power source. Okay? Okay, so we're going to plate this spoon with silver. And so our solution has to have an electrolyte, and we're going to make it silver nitrate. Silver is going to come off of this electrode, silver ions, and it's going to come onto this spoon. Okay? So the desired metal to plate with is always at the anode. And what needs to be plated is the cathode. Okay. So what reaction is happening at the anode? Oxidation. Oxidation always happens here. And over here, then the cathode must be
Production.
okay. So the big thing to note here when you're looking at a diagram is what is the source? Does it say a V, which means a voltmeter? You're dealing with a voltaic cell. Is it a power source? You're dealing with an electrolytic cell. Okay? So notice that the oxidation and reduction are the same reaction. It's just in reverse. Okay? okay? It's still non-spontaneous. So we have a electroplating practice problem. It's asking you to look at an iron bar that's going to be electroplated with zinc. And you're going to draw and label a diagram, and you're going to follow those 5 points.
Like we do it.